Hi, in this video we're going to learn about logarithms. Specifically, we're going to learn how to convert. Before this lesson, you should have learned about exponential function. An exponential function can be written into logarithmic form. And that is your objective. At the end of the video, you should be able to write equivalent forms for exponential and logarithmic functions. Here is your basic concepts. The symbol log is short for logarithm, and the two are used interchangeably. The equation y is equal to this expression is read as y equals log base b of x, means y is the exponent we place on b to get x. We can also think of it as answering the question what exponent on b is necessary to get x. That is why y is the number that makes the equation b raised to y is equal to x true. As you can see, the logarithm can be basically explained as in exponential form. And that is why we should be able to learn how to convert logarithmic to exponential and exponential to logarithmic form of the function. You can write an exponential equation as a logarithmic equation and vice versa. Here is the exponential form and here is your logarithmic form. Remember, b should be greater than 0 and b is not equal to 1. This is read as logarithm. The logarithm base b of a is x. The logarithm base b of a is x. Notice that the logarithm is the exponent. The logarithm is the exponent. Okay. So, this is the first lesson we will learn about logarithm. How do you convert? We are going to learn how to convert from logarithmic to exponential, and then afterwards the reverse. How do you write the exponential form of the following logarithmic form? Here's your guide. Logarithm base b of a is equal to x can be transformed into exponential form b raised to x is equal to a. Just watch out for your variables. So, therefore, this becomes 9 raised to 1 is equal to 9. The base of the logarithm becomes the base of the power. Here it is. The base of the logarithm becomes the base of the power. The logarithm is the exponent. The logarithm, this is the logarithm, it will be the exponent in the exponential form. Let's have another example. You have here logarithm base 2 of 512 is 9. Therefore, 2 raised to 9 is 512. Logarithm base 8 of 2 is equal to 1/3. Why did it become lower? Because 8 should have an exponential exponent to make it smaller, which is actually cube root of 8 is 2. If you have a negative value of logarithmic, it means it is the exponent, it becomes negative, and so this is going to be a fraction 1 over 4 squared, and 4 squared is 1 over 16. How about if you have log base b of 1 is equal to 0? It means a logarithm can be a negative number. It's actually explaining here. Any non-zero base to the power, zero power is 1. b raised to 0 is equal to 1. Therefore, this base b goes 1. Any base number logarithm base of a number equals to 1, it means the exponent is 0. Okay. Now, let's have some more example. Now you have your exponential into logarithmic form. This is your guide. If you have an exponential form, your b becomes base, your exponent is going to be the logarithm. A is going to be your number next to the logarithm. So here it is. The base of the exponent becomes the base of the logarithm. 3 becomes the base. 5 is your value on the other side. 243 is your value next to your base b. It's just saying how many times 3 is multiplied to itself to get 243. 3 is multiplied 5 to itself to become 243. Next example, you have 25 raised to 1/2 is equal to 5. If we are going to rewrite it, logarithm base 25 of 5 is equal to 1/2. Okay, how about this one? The exponent is the logarithm. The exponent is the logarithm. The logarithm are the value on the right side. So 4 goes on the right side. It's going to be logarithm base 10 of 10,000 is 4, is equal to 4. Logarithm base 10 of 10,000 is equal to 4. It's just saying how many times 10 is multiplied to itself to become 10,000. The answer is 4 times. How do we write this in logarithmic form? You have logarithm of base 6 of 1/6 is equal to -1. An exponent or logarithm can be negative. So your base cannot be negative for your logarithm, but your exponent is actually going to become, can be a negative, your logarithm. So here, this is gonna be your general guide. Logarithm of base a of b, no, logarithm of base a of c is equal to b. The log and the exponent can be variable. Let's have some more exercises. So write each exponential equation in logarithmic form. This is going to become logarithm of base 9 of 81 is equal to 2. The base of the exponent becomes the base of the algorithm of the logarithm. So here, letter B, base logarithm of base 3 of 27 is 3. The exponent of the logarithm is going to become your base. This 3 goes on the other side. 27 is going to be your base. X raised to 0 is equal to 1. This is a trick question. So logarithm of base x of 1 is equal to 0. The logarithm and the exponent can be a variable. The logarithm can be a variable. Okay, let's have some more. This time it's logarithmic and we're going to write it in exponential form. So logarithm base 10 of 1000 equals to 3 is written as 10 cubed is equal to 1000. The base of the logarithm becomes the base of the power. Your second example, logarithm of base 12 of 144 is equal to 2. It's actually 12 to the power of 2 is equal to 144 in exponential form. The logarithm is the exponent. The logarithm is your exponent in your exponential form. How do we write this? 1/2 raised to -3 is equal to 8. That's your exponential equivalent of logarithm base 1/2 of 8 is equal to -3. It's written as 1/2 raised to -3 is equal to 8. How did it become a whole number? Remember, if you have a negative exponent, your base will flip. So it becomes 2 cubed. 2 cubed, 2 times 2 times 2 is 8. Okay. Here are some special properties of logarithm. A logarithm is an exponent, so the rules for exponents also apply to logarithms. You may have noticed the following properties in the last example. Here, for any base b such that b is greater than 0 and b is not equal to 1, logarithm base b of b is equal to 1. Of course. How does b becomes b? Nothing has changed. The exponent is 1. Here's your example. Logarithm of base 10 of 10 is equal to 1. 10 raised to 1 is equal to 10. Here's your logarithmic form, exponential form. That's your logarithm of base b. If you have logarithm of 1, this is actually your some kind of identity of logarithm. Logarithm base b of 1 is equal to 0 because the exponential equivalent of it, b raised to 0, is equal to 1. Logarithm base 10 of 1 is equal to 0. 10 raised to 0 is equal to 1. This is your logarithmic form and exponential form. A logarithm with base 10 is called a common logarithm. So this is the special case of your logarithm. If no base is written for logarithm, the base is assumed to be 10. This is what you need to watch out for. If there is no base, it is actually 10. If you have a variable and there's no number in front, it means there is 1. If you have a logarithm and if there's no number, it means 10. The base is 10. You can actually use mental math to evaluate some special logarithm. So evaluate without a calculator. So you see there's no number, it's actually 10. 10 raised to a number is equal to 0.01. The log is the exponent. So what number do you raise to make 10 become 0.01? It's actually negative 2, because if the number increases, the exponent is negative. Because this becomes 1 over 10 squared. 10 squared is 100. 1 over 100 is 0.01. Therefore, the logarithm of 0.01 is equal to negative 2. It is assumed that there is a logarithm of 10 if there is no number written. It's just like if there's a no number in front of variable, it means there's 1. If there is no base on your logarithm, it means 10. Okay? How do you evaluate without a calculator? If you have logarithm base 5 of 125, you're just going to figure out 5 raised to a number is equal to 125. Therefore, it's actually 3. 3 is the exponent of 5 multiplied to itself, it becomes 125. And that is the idea of logarithm. How many times 5 is multiplied to itself to become 125? And that is your logarithm value. Let's have another example without a calculator. Logarithm of base 5 of 1/5 is equal to negative 1, because 5 raised to negative 1 is equal to 1/5. Logarithm of base 25 raised to 0.04 is actually 1/4. No, it's not. Let's see. It's negative 1 because you have 1 over 25 in your calculator is 0.04. Okay, and that's it. If you need to watch the video again for a review, you should, and hopefully you are able to convert exponential form into logarithmic form expression and vice versa. Thank you.